works that traditionally is used. We tend not to talk in terms of displacement directly, even though, if you try describing to someone how to get from one place to the other, you're probably not going to give you longitude and latitude. First you go to 34 degrees north and 37 degrees west, and then travel to, you tend to be where you're starting, how do you get there. All right. If I died in the room where I was born, what would be my displacement for my life?
0.
Yes. Because I haven't gone anywhere. It's where I am relative to my starting point. So if I'm looking at my whole life, my starting point was in some room in Florida. If I die in the same room, my displacement for my life is 0.
Even if you traveled around and then went back to the room
Yep.
again?
The displacement, so let's talk about the two different types of displacement.
That's where I got confused.
All right, there's overall displacement
Okay.
and there's instantaneous displacement. If I just say displacement, I mean overall. Overall is the default. If I want you to find the instantaneous displacement, I have to use the word instantaneous.
Okay.
Now, overall displacement is based upon the starting point. The starting point is from where, in my life's journey, my starting point was in a hospital in Florida. If I consider my starting point for today, my starting point for today was in bed at home. So my starting point basically changes depending upon what kind of problem I'm looking at. Or my starting point for this class was in that chair because one class ended, the next one began. Question?
Overall, could you let me know how you got your numbers for 127 degrees?
Okay. I started out with the assumption that Winston-Salem is 200 miles due north of Columbia, South Carolina. And then I said, as part of this scenario, I said, after class, if I go 150 miles west to someplace, go home. My position now is from here, so because I made that due north and due west, that's a right triangle. And so Pythagorean theorem will get you that. Right. I say Pythagorean theorem like everybody knows it. Just in case, or it's been a while, that if you have a right triangle,
90 degrees.
so we've got a right angle right there, where sides A, B, and C, then A squared plus B squared is equal to C squared. So that side squared, that length squared plus that length squared equals that squared. If A squared plus B squared equals C squared is true, then it's a right angle. If one is true, the other two are true. A right triangle, I should say. So I made this deliberately a right triangle so that I could do this. This is a classic 3, 4, 5 triangle. The ratio of the sides, if I divide each of these by 50, that's 3, 4, and 5. 3, 4, 5 triangles, because I've done this enough, I know that's about a 37-degree angle. That's how I got that.
Okay, so that was just something you knew.
Yeah, I picked those deliberately so that I could do that angle.
Okay, so now you have the 9 degrees and you said the 37 degrees?
Yes.
Okay.
And those, just because, even though for I hat, J hat, whatever direction we say it is, or positives, whatever we say it is, the one conceit I will do that we don't have to define every time is, as you're looking at something, that way is positive, that way is 0 degrees, these are positive angles. So that's 0, 90, 180 degrees, 270, and so on.
So that's how you got the 1.
Yes, 90 plus 37. You good? Yes.
I think displacement, like for that one, when you first went to the top, would that be 0 or you went from?
Oh, my displacement when I'm here,
Yeah.
my displacement, if I'm considering this my starting point, because I was talking about, I'm here now, then my displacement is 0. And then it eventually ends up being 150 miles west.
And that would be negative.
I stuck with north, south, east, west instead of plus and minus.
Okay.
If you want to make, we could put it in terms of, given that convention, yes, that would be the negative direction. But, yeah, I was thinking of those as two separate problems. Yes,
So,
Christina?
if we don't write the negative or positive, like, will we get points taken off, or is it,
So on this problem right here,
yeah,
on this problem right here, you need to somehow indicate direction. And so I indicated the direction by just saying that's west, that's north, so that's west.
okay,
If you want to just define east, you can call it negative east, if you want.
as long as west or east is placed, then it's fine.
Yeah. Somehow accurately describe the direction so that I can look at it and go, yeah, I know what they're indicating that way. Other questions? By the way, back to the plus minus zero game, what is my displacement now? There was some weak answers there. Try that one again. What's my displacement now?
Positive.
My position?
Positive.
My position?
0.
My displacement?
Positive.
Position?
Negative.
Displacement?
Positive.
Position?
Negative,
Displacement?
0.
0. We do have potentially a parallax coming from here to over there. Jasmine might see me as being on the negative side, whereas Genesis might see at the origin. The intent was on at the origin, or sorry, at the starting point. And now my position
Negative.
and displacement.
Yeah.
There was a little less confidence on that last one, but yes, for those who spoke, it is negative. Actually, for those who didn't speak, it's still negative. All right, you ready for the next one? Oh, I didn't talk about instantaneous versus overall. Sorry, I want to get to that first before we do the next one.
The 250 is the positive, right?
That 250, I indicated 250 by the angle. Okay. Overall displacement, wherever you are relative to where you started, whatever the problem is. Instantaneous is where you were compared to where you just were. So if I'm walking this way, my overall displacement is positive. My instantaneous displacement is negative. Because as I'm walking in that direction, so as I'm walking in that direction, I compare myself to where I just was, which was right there. So instantaneous displacement is where you are compared to where you just were. It indicates which direction you're moving. Overall displacement is typically the more interesting question, at least from my point of view. All right, next. Velocity. That is a V with a vector symbol over it. Lowercase v. It, of course, has two different definitions. It is how fast an object is moving and in which direction. Or it can be defined as the time rate of change of position. Now the second one, like potentially the awkward wording for some of you, the second one leads itself to a math formula. The first one really is helpful in indicating the plus minus of 0. Velocity is positive when you're going in the positive direction. It's negative when you're going in the negative direction. So we didn't do that for displacement here. So displacement is positive when on plus side starting point. And velocity is positive when moving in positive direction. Velocity does not care where you are. It just cares about how fast you're going and which way are you going. The second one, definition, leads itself to a math equation. It leads ourselves to the velocity equals the change in position over the change in time. Or displacement over time, if you want to shorten that. All right, so let's just first start out with plus minus 0. Same origin, same starting point, same positive direction. My position, positive, negative, 0. You've been stunned.
I was.
Try that one again. My position, positive, negative, 0.
Positive.
All right. My displacement,
Positive.
my velocity,
0.
all right. My position,
Positive.
where am I relative to the origin?
Positive.
My displacement,
Positive.
my velocity,
Negative.
my velocity now,
Positive.
my velocity now.
Negative.
Good, good. And yes, so where I am is not important for velocity, it's where I'm going. There are two types, of course. There's average and instantaneous. Average and instantaneous. When I am asking for the velocity, the default is instantaneous. If I want the average velocity, I need to specify the word average. Technically, this formula right here is the formula for average velocity. In order to get instantaneous velocity, the time frame has to be incredibly tiny. In math terms, the limit is 0. So, yeah, and we'll delve into that more. All right, do another round of plus minus 0, and then we'll hit the other one. Oh, wait, no, then I'll talk about your single. Then what the other? My velocity,
Positive.
my position,
Negative.
my displacement.
Positive.
All right, feeling good. Now, I'm aware not everyone's speaking. Those who are silent, I hope you were just being shy as opposed to, you have no idea what's going on and are afraid to ask a question. Yes,
So if you're walking this way, it's positive, if you're walking that way, it's negative.
yes, because I said the rate was positive. Yes,
So in reality, displacement and velocity are both, it depends on the wording of
yes,
the equation or whatever?
yeah.
Okay.
All right, simple. Let's just pretend I'm in a race with Usain Bolt. I think we'll just, if you don't know who Usain Bolt is, fastest man alive, or was at one point, I think he still is. We're racing on our track. Once around, Usain Bolt and me. Gun goes off, we start, we race around, he gets all the way around in 40 seconds. I get around in 240 seconds. Who has the greater average velocity.
Who's
Pardon?
saying? Who's,
Why would I?
who's saying?
Oh, you said who's saying? You said you?
I said you.
Yeah, why would I have
Wouldn't
greater?
a greater average be longer in time?
No, let's think about the math definition here.
Speed.
What was Usain Bolt's displacement when he finished? Yes, what was my displacement when I finished? What were our velocities, average velocities? Yes. When we finished the race, we hadn't gone anywhere. Now, he did it in less time than I did, but in the end, we hadn't gone anywhere. We ended up back where we started. So, I'm as fast as Usain Bolt. Let's take it one step further. He finishes. At 40 seconds, he is done. He is back where he starts, and I am here. Now, who has the greater magnitude of average velocity?
You do.
Because after 40 seconds, I'm at least somewhere. He is back where he started. He has gone nowhere over 40 seconds, whereas I have gone somewhere. My displacement is that vector right there. That's my displacement. His vector displacement is a dot at best. I'm faster than Usain Bolt. Physics is there to make you feel better by manipulating the words. Questions before we hit the last one, the one that is it's the one, if you're gonna have trouble, if you're gonna have trouble with one of these, it's the last one. All right, I got it. You bet the Naya.
So if he's at halfway and you just barely started,
Oh, you have a higher. So I picked up my speed, must have, because by the end, I'm greater average. We don't look at that.
we don't look at.
For that last point that we did, would that velocity be measured?
All right, positive or negative, we're dealing with one dimension, I can get away with plus, minus. So if we're gonna treat this like a two-dimensional problem, then I have to bring in I hat, J hat. And so, if I make I hat to the right and J hat up, I'm pretty sure I did I hat, J hat in the beginning.
No.
This is,
I haven't done I hat, J hat.
this is their introduction to it.
I apologize. Well, as if you had read my mind, you. All right, so when you're dealing with a two-dimensional problem, you have to describe a vector. You do need to come up with some indication, because you can't have just a positive direction, because if I say to the right is positive, and I have somebody doing that, and someone else doing this, well, they're clearly not the same direction, so I have to somehow add something to it to indicate one is to the right and up, the other is to the right and down. So, instead of writing to the right or up, just again, too much writing, we need to write that in as little as notation as possible, and so we bring in the unit vector. Did I talk about unit vectors? I'm getting some head shaking, no, your eyes say yes. All right, a unit vector. Remember, all vectors have a magnitude and a direction. The magnitude of a unit vector is, let me say that again. What is the magnitude of a unit vector? I hear a noise. I'm not trying to refer to a word. Unit.
Units.
It's one.
Yes, thank you. One. Spanish, Latin, French, they all got that U in there for the, not because it's not something on, but for French. French pronunciation sucks, but anyway. Unit vector has a magnitude of 1. All unit vectors have a magnitude of 1. No units, just 1. You can tell a unit vector because it's got the hat on it. If you're using LibreOffice or OpenOffice formula editor, hat is the keyword. You write hat and then brackets I, and then would come out as I with a hat over. This is how you deal with direction for 2 dimensions. So if I say that I hat is to the right and j hat is up, then at this point right here, I'm in the negative I hat, negative j hat direction. So you can't just get away with plus or minus, you have to add a little bit more detail. If when I am here, I'm in the positive I hat, negative j hat direction, because I'm to the right, positive, and down, negative j hat. So that thing I had on the board before, if I establish I hat and j hat, say I don't feel like writing the word north out or west or anything like that, I could say that my initial position, instead of 200 miles north, I could write 200 miles j hat. I said j hat is in that direction. My displacement is 150 miles. Well, I said that was I hat, so that would be negative I hat. Now the minus sign traditionally goes in front. If you want to put the minus next to the I hat, be careful about that, because the students that I've seen do that have a habit of writing it like that, and that is a subtraction problem.
Yeah.
If you want to put the negative next to the I hat, you need to put that in parentheses. Or stick the minus in front, like most of us have gotten used to doing. Now, my final position, this right here, where I give you the magnitude and the direction directly with an angle, this is known as polar form. In what's called rectangular form, I could write my final position as 200 miles